So as we were talking about in our previous video, we were talking about the different types of structured data, categorical versus numerical, and how categorical data can break down in nominal and ordinal. So kind of in brief, categorical data is data that where we can put into certain categories, so gender, perhaps age ranges, et cetera, months, days of the week. These are all categorical data, but some of that categorical data can be nominal, meaning that gender doesn't matter what order it is. However, ordinal data does. So Monday, Tuesday, Wednesday, Thursday, Friday, that order matters even though it's still considered category. And then numerical data are things like temperature, count values, et cetera, et cetera. So however, interval data is usually things like temperature or continuous values where you can measure one minus the other and then it creates an interval. However, a ratio might be something like counting something as well. So like count the number of dogs, count the number of cats. You'll be able to measure the difference, but really we might be looking at the ratio of cats over the total number of pets. So count is typically more of a ratio item, and then interval would be kind of like temperature or continuous values. So let's look at unstructured or semi-structured data. So text data, multimedia, of course what we have here, and XML, JSON data is considered to be unstructured or semi-structured. And these are really basically the types of data that mean something to people when it's observed, but it needs to be processed in a way to make it structured data. So I'll give you an example. Like in a sentence, like if I say that it's raining outside, well, you can't put that into a number. You can't put that into any kind of category by itself. What you have to make a decision about is how are you going to process that piece of text. So what we might want to do is say that this is a statement about weather. Okay, so we have a checkbox say that that sentence is about weather. Then we say something that Bobby is 6 feet tall. Well, this is something about people. And we can go through like a series of sentences and start categorizing sentences that are dealing with people or weather. Right? That's how we transform something into some kind of structured data so that way we can process it better. And that's the same thing we do with all of these other types of data sets. So unstructured or semi-structured data ends up becoming something that we have to provide a structure for in order for us to make sense of it as we process it more. All right. So data processing is something that is really kind of an art. We have to prepare that data in a way that makes sense. So we have a lot of pre-processing requirements, which means we may have to consolidate data, clean it, transform it, reduce it. And a lot of people call this, well, this is data manipulation. Well, the argument comes down to, is the data that you have ready for analytics? Obviously, if I have a bunch of data, and this data is talking about, using my previous example, a combination of weather and people, and really what I want is the data that is representing the weather, I want just to take that subsection of data and then boil it down into something that I can use. Well, that is not necessarily manipulating the data. It is filtering out and processing it so that way I can analyze it. So this whole idea about processing data is not about manipulating it, but more or less making it so that way it will answer my analytics question. So there's several steps that we go through when it comes to processing our data. A lot of times we talk about our data sources, and then we consolidate it, clean it, transform it, and then of course we reduce it a little bit more. And across each of these steps, we're going to do certain things that will require us to maybe go back and then iterate over our data in a different way because we found something that is not appropriate for our data analytics. So this is something that we do over time. And I always argue, or I would pose the argument that when it comes to data analytics, this idea about pre-processing is really 80% of the data analytics function. It's one of the most important things, and if this is wrong, then your analysis is really worthless. So in your textbook, in Table 2.1, there is several examples of processing steps and what are some of the tasks that can be done, and then giving you some type of methods in order to be able to accomplish those tasks. And there's a variety of these types of things that can occur, and a lot of times when it comes to large data sets in organizations, sometimes people will become experts at one aspect. Like, so for example, they might be experts at data cleaning, but they may not be great at data reduction, right? So all of these types of tasks end up having some kind of meaningful aspect in the data analysis process. So let's start talking about modeling for business analytics. Right? So for the most part, we're going to be talking about descriptive analytics here, but as we mentioned in our earlier chapter, there's also predictive and prescriptive analytics, right? And the key thing here is knowing that descriptive analytics really deals a lot with what has happened or what is happening in the current aspect of our data, right? Predictive deals with what's going to happen, and prescriptives provide some analysis that can give you an optimal solution and prescribe on what to do next. And also, descriptive analytics and data visualization is considered to be low in complexity. And if you're a business, it may not give you that much competitive advantage as some of these other tools that are in the upper right-hand corner. So descriptive analytics kind of sits in this area. And then as you move up in predictive and prescriptive, you increase the complexity, and then you increase the competitive advantage that these types of tools will provide a business. So statistics and descriptive statistics, and what does this really apply for us? So statistics is actually the tool that we're going to use to be able to get us some kind of idea about our data sets and what has happened. And so we need to understand our data, what variables that we're using. And what I mean by variable is, so data might be the numerical representation. Like earlier, I said it could be like a number 2. 2 what? Well, that 2 could be the number of dogs, or it could be the temperature that day, or whatever it might be. And that temperature is considered a variable. Right? Observation is that how many times did you record that? How many days of the week? All 7, or maybe just 2? What are the variations between those observations? And is there some kind of randomness that occurs that is caused by something that we can't figure out? These are all key to that scenario. So here's a little bit more greater detail with the types of data. What I'm going to do is I'm going to pause right here, and we'll pick up the types of data as we kind of move forward in the next lecture.